Hi and welcome to the introduction to Ansys meshing for FEA. So today in this workshop we will be seeing Ansys meshing methods on FEA models. So in this workshop we will introduce different meshing methods available in Ansys meshing. So our objectives will be automatic TET patch conforming, multi-zone, Cartesian, decomposition for sweep meshes and automatic TET and sweep mesh. Alright, so let's get started. So first, in the component system, take the mesh and drag it to the project schematic. And now the geometry that I have provided for you, import the geometry. Click on this component STP. Alright, and click open. And now let us double click on the mesh. It will be opening. So in the previous video I had told you, if you right click and click on edit using space claim, uh, if you click on edit, then it will be opening the mesh as well, and if you double click on the mesh also, you can open it. Okay, now first thing you need to see is the units. So change this to meter metric. Okay, and now this CAD file contains a single body representing a component in the ventilation system. Alright, almost all mesh methods can be applied here. The selection of which method to use depends on speed, memory usage and requirement of defeaturing and any mesh specific solver restrictions. We will demonstrate how different methods are applied and highlight important differences in the resulting meshes. Alright, so let's get started. Click on the mesh here in the project outline, and now in the defaults, make sure the physical preference is mechanical, and coming to the sizing, change this adaptive sizing to no. Alright, and next coming to the capture curvature, make sure you need to activate this. Okay, and next coming to the quality check, um, in the error limits keep this as standard mechanical. Okay, and coming to the mesh matrix, keep this as element quality as well. And now let us generate the basic mesh that Ansys is giving for you. Okay, let us click on generate. So now for viewing isometric view, you need to right click on the screen on the graphics window and click on isometric view. Okay, so you can view the mesh here, right? So the automatic method has selected the tetrahedron method using the patch conforming algorithm here. So the mesh was conformed to all geometry details, right? So now let us create a section plane. Click on the Z axis and now go to the section plane and let it be at the center and drag it downwards. Yes. So now restore the isometric view. Alright, this is fine now. So if you view the mesh, we can see how the 3D elements are formed. So the default automatic method always uses the patch conforming tetrahedron or a sweep depending on the geometry. In this, the non-sweepable cases just patch conforming tetrahedrons were used, right? We will now look at how other methods can be accessed. Now just switch off the section plane and next let us insert a method. So right click on the mesh, click on insert, and here you can see the method. So in this, select the entire geometry and click apply. Alright, and now here in the method change this to multi-zone, and here in the free mesh type keep it as tetra and pyramid. Alright, and then in the mesh details change the element size to 0.005. And now let us generate the mesh and see how the method we had used. And now if you view the mesh, so the multi-zone has generated all quads on the surface mesh, right? So note again the automatic defeaturing of the small imprinted faces present on the geometry. Okay. So now if you switch on the section plane once again, you can see in the internally it divides models in blocks and fills the blocks with hexa wherever it is possible. Okay, so in the remaining areas blocks with it creates a tetra and pyramids, you can see in this area. And now if you check the element quality as well, you can see this, right? So these are the tetra and the red ones are the tetra elements and pyramids are this. All right, so now let us switch off this section plane and get back to details, and in the multi-zone let us use the Cartesian method. Alright, and now let us generate the mesh once again. You can see the mesh was generated, and if you switch on the section plane, yes, and now if you notice that by using the Cartesian method you can observe and you can view the mesh quality as well. Here everything is 100% hexa mesh, right? So there are no tria elements here. You can see here only hexa is been identified. And now let us again switch off this section plane, and now let us save this project. Let us close this, and now save this project as AMWS FEA. Yes, 2 underscore FEA. Alright, let us save it. And now we will be seeing how to do a sweep meshing. Alright, so the sweep method can produce high quality hexa meshes. So in order to generate sweep mesh, we must have sweepable bodies. I will show you how to check we have sweepable bodies or not. Just open the mesh once again. And now, if you want to check you have the sweepable bodies in your geometry or not, just right click on the mesh and here go to the show option and click on sweepable bodies. You can see none of the faces is highlighted because we don't have any sweepable bodies. But we can generate the sweepable bodies using Ansys design modeler or space climb design modeler. So I will show you how to create a sweepable body. Okay, let us close this and open the geometry. One more thing guys, while opening the geometry, if you right click, you can do the geometry changes using two tabs. One is using the space claim or and the other one is using the design modeler. Okay, it's your choice. So I'm showing you how to use in the space claim. Okay, now you can see the body here in the workspace. And now let us create the sweepable bodies. So for that, first let us fill these holes. Okay, these are not necessary actually. So if you click on the fill option and select the face here, and if you click on this tick mark, you can see the holes are filled. And now, so to create a sweepable body, this has to be disconnected with the total entire body. You can see the total body is represented as single body. So I will show you one method. So first let us delete this face here, and then let us create a circle. So let us enter it as 30 mm diameter. And now let us return to the 3D module. And now first let us delete this face. Okay, so this face actually represents this total body. Okay, so we don't need any connections between them. So for that let us delete this. And now if you click on this fill option and select this inner circle and let us click tick. And now we need to reduce the size. So for that go to the pull tool and now reduce the size. Okay, okay, enter it as 5 and now you can see it's exactly matching. And now what you need to do is after click on the pull tool and click on this sweep method and then okay, press escape and first select this face and click on the pull tool and then click on the sweep method and select the direction you want to pull. So this is the direction I want to pull and now click OK. And here you can see there is an intersection, right? So press escape and let us go to the repair tab. Let us check interface. Okay, so now um, the design tool, click on the split body. Okay, and then select this body and we need to select the plane which we want to cut. Okay, and then this asks which region you want to remove. So we want this down region to be removed. Alright, and now you can see this total body is represented as a solid body. And if you hide this And now let us click on this fill option here and click enter. Alright. Check any gaps, no gaps, okay. Okay, in the similar way we will do the downside as well. So let us delete the face and then go to the sketch tab and sketch mode, okay, and let us insert a circle 30, fine, and let us come back to 3D mode and let us remove this face and fill this face and then press escape first and then go to the pull tab and reduce this by 5 mm, and now it is fine. And now let us use the pull option again. First press escape, select the face, go to the pull option and click on the sweep and select the direction you want to sweep. No. And now press enter. Yes, this is fine. And you can see the second body is also been generated, solid body. And now same thing, go to the repairs tab okay, in the design tab click on the split body, select the body and then select the plane you want to cut, and then we don't want this lower body, right? And now press escape. And one more thing, let us hide this solid bodies and then let us fill this as well and make it as a solid body. Fine. And now these both bodies are solid bodies are sweepable bodies and this part is a non-sweepable part. So again go to the component and make sure turn on this share topology to share option. Alright, and then close this. And now let us reopen the mesh. It asks you need to update, okay, so let's click yes. And now you can see a question mark. It is asking about the Cartesian that we had performed, right? So just leave it like that. So let us cancel it, delete this. And now we need to see whether we had formed the sweepable bodies, right? So go to the show option and now you can see both the sweepable bodies. Alright. So now let us apply a mesh method. Okay. So again go to the method. Okay, we had selected the geometries as these two bodies, and here in the method click on sweep and coming to the source, here uh, target selection is manual source and we need to select the source. So click on the stop faces and click apply. Alright, and coming to the sweep number, let us give it as 10. And now let us create another multi-zone method and click on this method and select this body and click apply, and here we will use multi-zone method. Alright, and here in the free mesh type use hexa dominant. Yeah, hexa dominant, and then let us generate the mesh now. And now let us activate the section plane and let us see inside. Alright, so you can change the free mesh method here. Let us deactivate this and change this to tetra and check the details as well. Let us generate once again and check the mesh quality here. Alright, so this completes the workshop, and now let us close the mesh and save this project. So thank you guys. In the next session we will be seeing about the global mesh controls. Okay, so thank you.